In this video, I'm going to talk about the air handling and fan coil unit. Just like a pump that circulates water around the building, a fan is also required to circulate air around the building. So pump is to water and fan is to air. And for air loop, you will need the AHU or FCU, which has a fan inside it for this purpose. So this is a typical looking AHU or air handling unit. So in front here, there is the supply air fan, and usually the supply air duct is over here, supply air duct. So cold air actually is being pushed out from here and go to the area that you need to cool down. Alright, and in front of the air fan, there's the cooling coil. Okay, so air will actually get treated over here, either get cooled down or heated up. Because in this AHU, there's reheat coil as well. This is the heating coil, and this is the cooling coil. So as you can see from the pipe over here, chilled water will flow in, and after that it will come out as return water. Alright, so the air conditioning process will happen at the cooling coil, and before passing into the cooling coil, it will be cleaned up by the air filter first. So these three components are inside every AHU. And AHU are installed in AHU rooms. Okay, it's somewhere that is not accessible. Usually it's at the one corner of the level. And inside the AHU rooms, there can be multiple AHU. So for example, in this particular picture, there are around four of them, 4 big AHU inside. And because it's also very noisy, usually it's being confined. Alright, it's being insulated. The doors are insulated so that the noise don't get out. And there are two types of air handling unit. Okay, one is called constant air volume, CAV. The other one is called variable air volume, VAV. So we are going to look at the differences between these two AHU. First, let's look at constant air volume. So constant air volume, as the name suggests, is the amount of air that's coming out from the diffusers are fixed. So for example, all these squares are the diffusers where cold air comes out. So let's say it's 1000 cmH, you design for 1000 cmH, and no matter what happens, it will always supply this amount of cold air to each individual air diffuser. So you are not able to modulate. You are not able to say I want 500 cmH or I want 1002 cmH. You are not able to do so because it's constant air volume. Okay, so you may be wondering, then how am I going to control the temperature? If let's say inside this room, the load start to reduce during the evening time, and the temperature sensor actually picked up that it's getting colder and colder in the room, and you are still supplying so much cold air inside. So how are we going to change the temperature? The answer is very simple. There's a temperature sensor at the supply air duct. So this temperature that is supplied to the room, maybe during the daytime, during the peak hours, is around 14 degrees Celsius. And let's say during the evening time when the load start to reduce, you can actually increase this temperature. So we should try to supply an air that is higher in temperature. So maybe instead of 14, it increased to 17 degrees Celsius. And if that is the case, then the return air temperature will be able to be maintained at the comfortable temperature of 24 or 25 degrees Celsius. So to adjust temperature inside the room, you will modulate the supply air temperature. So how do we change the supply air temperature? Then that is at the chilled water side. So at the chilled water side, alright, because the AHU will have a cooling coil that is carrying cold water and cold water into the AHU. So by modulating the amount of cold water that is flowing inside, you will be able to modulate the supply air temperature. So that is how temperature control is done. But the problem is, as you can see, there's no individual control. So let's say you change the temperature of the supply air, everyone will be affected. So all the diffusers will have the same supply air temperature that is coming out from the diffuser. Now, let's look at some of the advantages of having this system and the disadvantages. First, it's simple and reliable, alright, because there's not much components. It's simply controlling the temperature by changing the supply air temperature by modulating the chilled water valve. The capital cost is lower because there's not much components involved, just a air duct, all right, with a temperature sensor inside the room, all right. And the ease of installation and maintenance, all right, is also because of the lesser components required. And you will not have a problem of constant air movement. You will not have a problem of still air condition, all right. So because as I mentioned, no matter what happens, it will always supply the same amount of air from the diffuser, 1000 cmH. You are during a cold day, all right, let's say during a rainy day, let's say the temperature sensor suddenly picked up a very low temperature, then the amount of air that's coming out will still be the same, all right, so you will not have a stagnant air situation. Okay, how about the disadvantages? It's less flexible in operation because there's no way to have a part load operation. All right, so let's say the load reduces, what you can do is just to adjust the supply air temperature, all right, but you are not able to modulate the air speed, so it's not as flexible. And because it's less flexible and it can only supply a single zone, okay, you cannot have multi zones where you want one of the zone to have higher temperature, the other zone to be lower temperature. It's impossible to do so for a CAV AHU. And of course, because you are not able to ramp down the fan speed, there's less energy saving opportunities. Next, let's look at the variable air volume system, VAV AHU system. So VAV AHU system, there's this additional green box over here. This is what we call a VAV box. Okay, so these two are VAV box. So inside the VAV box, there's a damper. We call it the volume control damper, which helps to control the amount of cold air passing through. All right, amount of cold air that will flow through. So using the same example, let's say each diffuser supply 1000 cmH. During a cold day, all right, when the load start to reduce, you can supply less air. So instead of 1000 cmH, you can reduce it to 800 cmH or 600 cmH. So the air volume, the amount of air that's flowing through, can be adjusted. All right, it can be adjusted, and that will react with the temperature sensor. So the temperature sensor will control the damper position. So you can do it for one zone, and the other zone can still have the 1000 cmH. All right, that means you don't have to affect the other. Okay, so each individual VAV will take care of its own area. Okay, what if all the VAV boxes start to close? Okay, maybe during the evening time when the load is low, when it starts to close, then the pressure sensor will pick this up. Okay, because the static pressure inside the duct will start to increase. Okay, because of more closing of the VAV. And when static pressure start to increase, it will ask the variable speed drive to ramp down the fan speed. Okay, so there are two control loops you can see over here. One is the temperature control loop. Temperature will control the damper position. Second is the pressure loop, where the static pressure sensor will control the variable speed drive speed. So for variable air volume, let's look at the advantages first. So it is flexible in temperature control because now you are able to modulate the amount of airflow rate into the room. And there's chances for energy saving because you will be able to ramp down the fan speed when the load is low. And it's very efficient for multi-zone area. Maybe for a big office space, you have 4 to 5 different departments sitting inside there, all right, served by a single AHU. So all these different departments will have its own VAV box that will control the temperature of that particular zone. So there will be individual temperature control for individual zone. The disadvantages will be higher capital cost because now you have additional components such as the static pressure sensor, such as the variable speed drive. All these will cost more. It is less reliable than CAV system because of more components, more sensors. All right, the actuators for the VAV damper is one area where it can fail. The static pressure sensor, let's say, is installed at the wrong location, or it start to get inaccurate readings, then it may affect your controls. And you may have a situation of still air condition when the temperature is low and the VAV box will start to close the damper. So the damper will throttle to maybe 60%, 40%, 20%, 10%, or eventually maybe fully closed. When the damper fully closed, then there will be no air coming out from the diffuser. And that is when you have this still air condition, when the temperature feels okay, but because the air is so stagnant, you will feel very uncomfortable inside the space. Next, let's look at fan coil unit. So fan coil unit, this is one example of fan coil unit, which similarly, there will be these three items inside: the fan, the cooling coil, and air filter, all inside the unit itself. And this unit is usually located just at the ceiling. Alright, just at the ceiling of the space, or maybe just outside. Okay, so usually FCUs are installed at the ceiling, and most of the time, okay, if it's this type of fan coil unit, there will be no duct, okay, no ducting system. So the cold air will just return back through the grills over here, and the cold air will just come out from the louvers over here. Alright, there's no supply air duct or return air duct, but there are ducted versions around. Okay, and usually for ducted versions, then the fan coil unit maybe will be somewhere just outside the space, and it will supply to maybe 2 or 3 rooms or through air duct. So other than using AHU to distribute cold air, fan coil units are also quite commonly used. Alright, the concept is similar to direct expansion system, where cold fluid, cold refrigerant comes into the room, comes into the fan coil unit and leaves the fan coil unit, and the fan coil unit will blow out cold air. Alright, this is actually found at domestic, okay, at our home, alright, which is a direct expansion system with a fan coil unit. With chilled water flow, it's possible to have fan coil unit as well. Alright, so this is very useful for places with limited ceiling spaces. As we know, air duct actually occupy a lot of ceiling space. If you don't have such space, you don't have such luxury for having supply air duct, return air duct, then you may need to have fan coil unit, because it will take up much lesser ceiling space. It is also suitable for areas which require individual control, okay, independent control, not individual control. So that means, for example, a classroom may not be occupied for the whole day. So when there's no lesson, no one is inside, then the teacher, before leaving, he may want to switch off the air conditioning, switch off the fan coil unit. So when people start to occupy the space, then it can be manually switched on. So the manually switch on and off is suitable for for fan coil unit and not air handling unit. Air handling unit, it shouldn't be adjusted by the users. Okay, only fan coil unit, you can let the users decide whether to switch it on or off. Ductwork can also be connected for supply air and fresh air intake if necessary. So what do you think is a suitable air conditioning system for the retail sections of a shopping center and has a minimum fresh air requirement? So first, constant air volume will be quite suitable. Alright, and why is that so? And because there's a fresh air requirement and the space will be big, okay, will be large because it's large retail sections, then you should use ducted chilled water FCU, okay, chilled water FCU, and not direct expansion system, because direct expansion system, there's a limitation to the amount of area it can serve. Alright, so this will reduce the number of FCUs required. So a constant air volume and it's a fan coil unit. And there may be chances that some shop spaces may remain vacant. That means nobody occupy it for a period of time, and it doesn't make sense to still supply cold air into the room. So if it's a fan coil unit, then you can just switch it off, based on, for independent control sake, you can just switch off the fan coil unit that serves the space that is not occupied. So shopping center, because the load will not change as much, especially for retail spaces, the load will be quite standard. So the amount of individual temperature control will not be that necessary. So you don't really need to have a VAV AHU for the retail spaces, since the load will more or less be consistent throughout. And of course, CAV system has the advantages of low capital cost and minimum maintenance. Now let's look at the major differences between AHU and FCU. AHU are located in plant room, or usually we call it the AHU room, that is separate from the space that it serves. That means usually it's at one corner of the level. But fan coil units are usually at the ceiling of the occupied space. It's just above the occupants most of the time. And because it's away from the occupied space, alright, so it will be, the cooling coil will be outside the space. So cold air is produced outside the space, whereas for FCU, cold air is produced within the space. So you may think, why does that matter? If you have a condensation problem, you have a water leakage problem due to condensation, usually it's caused by fan coil unit most of the time, rather than air handling unit. So because the cold air is being produced right above, okay, right over there. So that may be one of the reasons. Maintenance of AHU can be carried out without interfering with tenant's business because it's located in the AHU room and not at the ceiling space of the tenant. FCU, on the other hand, is right inside maybe the shop spaces, or right inside the offices, which is just on the ceiling. And if you need to do maintenance like clean the filters or whatsoever, you have to go to the space and may interfere with the business and operation. A single AHU, it can serve a large zone, alright, easily 50 to 100 tons. So a larger fan, you can actually have it outside, okay, at the AHU room, and the noise level will also be contained over there. However, for large spaces, if you want to use FCUs, then you need to have multiple of them. Maybe you need to have 5 to 10 FCUs to serve the same place, for example, a big auditorium. Then, of course, all these may contribute to the noise level, which brings me to the point number 5. So the fan noise is confined within the AHU room, usually is well insulated, so the noise don't really affects the occupants. Whereas for FCU, is hard to prevent the noise level, because especially when the fan coil unit is operating at a higher speed, for example, a medium speed or high speed. And finally, the intake of outdoor air at AHU can be done easily through fresh air duct, okay, and it can mix with the return air duct before passing it into the AHU. So this can be done easily, or in the AHU room, you can just, let's say it's facing the external wall, you can just have a louver that can draw in fresh air. Alright, so you will be able to provide certain amount of fresh air into the space through this method. For fan coil unit, it's much more complicated and not as straightforward, because the fan coil unit is at the space itself, so you may need to have a small air duct that will help to draw in the fresh air, which may not be possible for all places. But it doesn't mean that in a building there can only be either AHU or either fan coil unit or either chilled water system or only direct expansion system. It is usually made out of multiple different types of cooling systems coming together and serve its purposes. So for a DX system, it's useful for night load, where the load is very low because there's only a few places that require cooling. For example, the server room, the security room. And the load can be as low as maybe 50 ton. Okay, let's say it's around 50 ton. It doesn't make sense to switch on a chiller of 350 ton to serve this night load. It's not economical, it's not efficient for the chiller, and it's quite detrimental to the chiller also. So it will be better to have a separate direct expansion system to serve these places 24 hours. And for AHU, it's suitable for large area with varying load, where people come in and go out, The load may increase or decrease day to day, and the VAV box will serve its purpose by opening or closing the damper for the changing load. And it's also suitable for large areas, large spaces like open plan offices, individual offices, etc. Whereas for fan coil unit, they are more suitable for areas with on-demand usage, such as meeting rooms, classroom, where when you need it, you will switch it on individually, or when somebody book the room, then the facility management team may help to schedule it to switch it on and off. So that will save much more energy rather than having an AHU that always serve cold air into the room even when nobody is using it. But of course, for larger areas, sometimes even for on-demand usage such as lecture theaters or exhibition hall, it can be served by AHUs also. Alright, so the AHU will be scheduled to switch on and off through the BMS, and it is more suitable in that in larger area because you don't need to have multiple FCUs as we mentioned. You don't need to have 10 to 12 FCUs to serve one auditorium. You can have one big AHU to do so. And I hope you have a better understanding of air handling unit and fan coil unit now.